So this is the last little bit of this. And I kind of wanted to start this a little bit earlier as opposed to doing this tomorrow. That way we've got a little bit more time to answer some more questions on it, because it seems to me that as we start this, every time I start this part of this unit, you seem to forget everything that you have just learned. Up until this point, you guys know how to set up sines, cosines, tangents. You know the whole idea of the SOHCAHTOA of how that all comes together. Sine is your opposite over hypotenuse. Cosine is your adjacent over hypotenuse. Tangent is your opposite over adjacent. You know how to use a squared plus b squared is c squared. All right? The 30s, 60s, 90s are still a little wishy-washy. Same with the 45s, but that'll come around in time as well. That'll give us things to go back towards. Well, what's going to happen now is that we're going to take this idea of solving a right triangle and if you think about it, anytime you have a right triangle, there's always going to be 6 parts. There's going to be 3 angles and 3 sides. Convenient, why they call it a triangle. When you have a right triangle, you automatically know one of the angles. Which one is it? The 90, the right angle, because it's a right triangle. I know, I'm going to back up here. It's a little confusing. So with that being said, there's only technically 5 parts then that we have to worry about. So quick reminder, when you use capital letters, those are always going to be for your vertices of the triangle. Those capital letters look at the lowercase letter opposite them. So angle A looks across its side A. Angle B looks across its side B. Angle C looks across its side C. This kind of falls into play then about the idea of little a squared plus b squared is c squared, because c is your hypotenuse. That's where that, using that kind of nomenclature started. Big angles are always, capital letters are always your angles, lowercase are always your sides. Does the same thing if there wasn't A, B, and C, if you had, I don't know, P, Q, and R. Well then across from Q would be little q, across from R would be little r, across from P would be little p. It's the same basic principle, just with different letters. It's a very, very common way that we write out right triangles via angles and sides. Okay? With that being said then, there's really only 2 possible scenarios that you can come across. When we talk about this idea of solving the right triangle, that basically means I'm going to solve for all missing parts. Well, if you are given two sides, if you are given 2 sides of a right triangle, how many other sides do you have to find? No, they're not proofs. And people keep asking because I say if you're given, well, you don't have to prove. Don't worry about that. But if you're given 2 sides of a triangle, how many other sides are there? 1. How many other angles are there to worry about? Well, 3, but you already know one of them. 2. So if you have 2 sides, that means you're going to have to find one. You're going to find, bless you, 1 side. Oh, and if you have 2 sides of a right triangle, what's the easiest way to find the 3rd side? Using what? Yeah, using the Pythagorean theorem. A squared, b squared, c squared. Does that mean you're always going to find the hypotenuse? Nope. You can find a side or a hypotenuse of one of the legs. It doesn't matter. It just depends upon the problem. But what I'm getting at is, one of the cases could be you're given 2 sides. So if you're given the 2 sides, find the 3rd one just using Pythagorean theorem. A squared plus b squared is c squared. Then you also have to find 2 angles using trig inverse. Because in order to find an angle, you have to use the inverse function. Okay? And then the other one is if you're given one side and one angle, if you're given one side and one angle, well, how many more sides do you have to find? Two. You're going to find two sides by using trig of your angle, and then you're going to find one angle via subtraction. And these are the only two possible things that happen. And when you see this written out as far as a problem is concerned, you're going to see real quick that it's a matter of just drawing out the picture and filling in what you're trying to find. You've done these problems before. You just haven't done two extra parts in one triangle. You've just solved for one side. You've solved for one angle. Now you're just going to solve for extra parts. Yes, ma'am? Yeah. Okay? That's what we're looking at doing. So let me show you an example. I show an example. In this example, I have one angle on one side. And as I go back into it, angle A looks at little a, angle B looks at little b, angle C looks at little c. We okay with that? What do you have to find? Well, which angle do you have to find? A. What sides do you have to find? Little a, little b. Well, let's start with little a. What angle are you given? Let me ask that. Besides 90. 70. Now, since I'm given this angle B at 70, I'm going to use the information that I'm given each and every time to solve for each part of these individually. Okay? There's a reason why I do that, and I'll show you in a second. Okay? So if I'm at that 70-degree angle, what is that side A in relationship to it? Is it the opposite or adjacent? It's adjacent. 12 is automatically going to be the what? Okay. What trig function is adjacent and hypotenuse? Cosine. So the cosine of 70 is little a over 12. How do you get a by itself? And just like always, you write down what you're going to put in your calculator before you put it in your calculator. Yeah. I'm sorry, my ears really clogged up. What's up?
I thought that
It is. It's pointing at the opposite. The opposite is the side B, but I'm solving for little a. I'm solving for A first, and I can solve for either side first. It doesn't matter. I just picked A. So. So now, when I do this, I type in the calculator around the 2 decimal places, what do you get?
4.10.
What was it?
4.10.
4.10, okay. So that gives me a 4.10 here. And now I go to the next part. The next part says find the other side. Well, the other side is side B, and now side B is the opposite. What trig function is opposite hypotenuse? Which one? Sine. So then I just do sine of 70 is little b over 12. So what you're getting at, did it matter which one of those two I found first, A or B? It doesn't make a difference. It doesn't make a difference at all. I'm just reusing the stuff that I'm given to start with to find the other parts. So when you type that in, what do you get? 11.3? 2.3 you said?
No, it's 2.7, what they changed. 11.28.
Yeah, 2 decimal places, remember. And now I've got my 2 side lengths. How do you find that last angle? Subtraction. Remember, when you have a right angle, or a right triangle, that means the other 2 angles that aren't the right angles are always complementary. What's the complement to 70? 20. And that's what we're doing. That's it.
Wait, how did you get that?
70 plus what is 90?
Wait, 20, yeah. I was doing 5s.
And the 2 angles that aren't 90 are always complementary. Just remember the rule of complements. Or just add all 3 of them together and subtract from 180. Alright? Does the same thing. Make it easier. Okay? So really, if you think about it, you've had to do this before. You had no problem. You had to do this one before with no problem. And you could do that all day long by the subtraction. So, quite honestly, all I'm doing here is putting all of it in one problem. And you're finding everything out about the triangle. That's it. That's all. Try that one. So in this one, you have 2 sides, which means how many more sides you have to find? And then how many angles you have to find? 2. So you list out what you have to find. I need to find, well, right now I have a little a, little b, I gotta find little c. I need to find angle A, and I need to find angle B. Easiest thing to find right off the bat is going to be angle C, or excuse me, little c. Because that is a what in the triangle? It's the hypotenuse. So just use your Pythagorean theorem. So throw in the calculator. 12 squared plus 15 squared is c squared. Well, the square root of 144, 225. 369 is what? 341? 341? Now, depending upon the problem, it might say, hey, knucklehead, leave it in simplified radical form. Or it might say, hey, bozo, round it to 2 decimal places. Now, your calculator will probably spit out in a radical form. Remember how to convert it? Double arrow. What do you get for a decimal then, just in case? You can cover your base.
19.21.
What was it?
19.21.
Thank you. And that gives you an idea. Okay? All I'm doing is hitting double arrow. Now you go back. Pick an angle to start to solve for. Does it matter which one you solve for first, A or B? Nope. Might as well start with A. If I start with A, I circle it. What two side lengths are given to me? If I'm at A, 15 is my, and 12 is my, okay? So what trig function are you using? Good. So the tangent of A is 15 over 12. You have to use the inverse button. Again, notice we're writing down everything that we would do before we put it in the calculator. Yes, ma'am?
So this will be a part where the higher number will be on top and the lower number will.
I told you before, don't ever worry, don't think about it. Just remember opposites and adjacents. Okay? What are you getting? Okay? So it tells me that angle A is 51.34. Now switch it around, go to angle B. If I'm at angle B, now what am I looking at? 12 changes. 12 becomes the opposite because I've switched positions. And that's the idea. You're going to switch positions, so you might have to, you'll switch your fractions. You might have, depending upon what side lengths you're given, you might switch the trig function. Here I'm still going to use, this is an opposite, and this is an adjacent. So I'm still going to have to use tangent. And just write it out. Press some buttons.
Yeah, 38.66. Yeah.
Why is this 54 then? It should be 50.
It's 51.
51. Okay, I was gonna say, wait, did I write down that wrong? 51.34?
Yes.
Thank you. 38, 66. Yes, ma'am.
So, instead of like for B, instead of doing like all of the hands, can we just subtract it, or do you want us to do the thing?
What happens if you accidentally type this into the calculator and instead of typing 12, you did 13? And then you got, like I did, I wrote down 58.32 or whatever it was. If you subtract that from 180 or subtract that from 90, would this ever be correct? No. No matter what, if this is wrong, if you do it that way, this will definitely be wrong. But if you screwed up here, but then you retyped it and you did it this way, do you still have a chance of this being right? Yeah. Never, that's why I always go back to the idea of always reusing your givens. Always reuse the givens within the problem. Just change your trig ratios if you have to. You won't come across that problem of screwing something up. It'd be harder to screw up. Excuse me. Let's try another.
Walk over there.
Please make sure that when you're doing the math part of it, as you're writing it out, I know it's so easy and so fast just to go right to the calculator. Write down what you're putting in the calculator before you do it, just like we always have. I'm trying to put a good spin on habits for you guys. It does pay off May not pay off as much as you think right now, but it will pay off tremendously when you get your trig unit in Algebra 2 by understanding ratios and how things are working with one another. It's so much easier to see. Excuse me. So, how many of each things do we have to find in this one? All of them, yes. How many angles? 2, and how many sides? 1. All right, label it. Well, little a, little b, little c, angle A, angle B. So start writing it out. How do we find the side length given 2?
A squared plus B squared plus C
Use your tag right there. Very good. So little a squared plus 15 squared is 18 squared. Oh, you guys have a calculator. I don't know. Press the button. What is it? What do you get? Great.
Like the whole answer,
Yeah.
A is 9.95.
Okay.
Or 3 root 11.
Okay. Thank you. Yes, ma'am. Yeah. So, found my first side length. Now, does it matter which angle I find first, A or B? No. Start at A. If I'm at A, 15 is a given side length. Is it an adjacent or an opposite? It's an adjacent. 18 has to be a hypotenuse. What trig function are you going to use? It's a hypotenuse which is across from a 90. So I'm going to be using cosine. Yo. Did I listen to Mackie? Sorry.
It is that, it is that. She did square root it.
It's, all right, 18 squared, subtract 15 squared, and then you take the square root of 99. You get 3 root 11. Get the,
I was just making sure you did it right, so save like a bunch of steps and I was still on space.
how do you find an angle?
How'd you get
Because it's next to me.
Okay.
Because this always looks at an opposite. So if this is an opposite, this has to be its, because this always is because it's across from that.
Okay.
So you inverse it. Get some numbers and things. Yeah. 3356. And now I switch gears. I switch angles. I go to angle B now. If I'm at angle B, 15 now is my opposite. 18 didn't change though, did it? Hypotenuse will never change. Your adjacents and your opposites flip-flop depending upon what angle you're at. So this becomes an opposite. So to find B, which are you going to use? Sine. So the sine of B and if you do these right, when you add those two angles together, they should equal 90. What is that? 50, 56, 44?
Yep.
I'm adding the 90 to 90.
Oh, okay.
I'm just guessing, because I know I set it up right, so I was hoping that I was close. All right. And that's what you're looking at doing. Writing the steps, showing them through, and going. Oh, I have it here. One more. I mean, seriously, I generally think that I've always been a rather healthy person. It's very rare for me to be knocked out or with a cold for an extended period of time. You know, I'll get sick from a day or two, but 2.5 weeks of this. I almost wonder if it has to do with the fact that it never got cold. It didn't kill everything out. So we have little a, little b, little c, and angle c. There's a tail there. So we need to figure out little b and little c. And I'm going to use angle A and the side opposite to figure that out. So if I'm at angle A, 21 is my opposite, little b is my adjacent, c is my hypotenuse. What am I going to do to find the adjacent? What trig function? Tangent. So the tangent of 50 is 21 over b. Exchange-o, change-o. $17.50. When I use my opposite and hypotenuse to find c, what trig function is that? Sine, good. So this would be now the sine of 50 is 21 over little c. Again, exchange-o, change-o. Oh, 27 what?
41.
2741, thank you. And that gives me my two side lengths. Now, what Ms. Topin had asked me while I was wandering around, should I use angle B to find anything? No, absolutely not. Hopefully you guys got 40 degrees for that. But I don't know how many times people see a 50 and they don't think about adding the 90. They think, oh, it's 100. And people will write down 50 degrees. And if you use that, will you even be close on the other ones? No. That's why you take your brain out of this. Don't reuse anything that you solve for. There will be a time that you will have to, but at that point in time, you're kind of forced to. But for now, try not to. Okay? It'll help take. It'll help to alleviate some of the wishy-washiness that can happen. All right? I got 6 of these for you. Those, and if I'll write it down, then I'll put them up. I should write that. Yeah, it's tough to find decent ones like this, so. There you go. That's them. You guys, that way if you don't want to look it up on your book, just take a picture real quick.